So we can define the volume as being 20 take away 2 x's, 10 take away 2 x's, which represent every possible number, and the height, which will become x, which represents, again, every possible height. We can actually type this into our calculator and see roughly what this looks like. What we should see is a x times x times x cubic function with a -2 times -2 times a +1 positive leading coefficient. So an odd degree with a positive leading coefficient should travel something like this, bottom left to top right. So we probably will come up, travel back down, come back up, something close to this. In fact, we can grab our calculator and type this in exactly as we see it. 20 minus 2x times a 10 minus a 2x times an x. Now, in our window settings, we probably won't see this exactly as we'd like because we're dealing with size of x as your cutout input, the volume as the output. We just saw 168 as the output. So let's change our window settings to represent maybe some better values. So the size of the cutout, it might be a little bit higher, let's say 20, and let's go from a -50 to maybe 250. Maybe the volume could be a lot more. And what we see, in fact, is this shape we might expect. In fact, if we're looking at some specific x-intercepts, we can calculate these quite quickly because we're in a factored form. X being a 0 is 1, because if you cut out nothing, 20 times minus nothing times a 10 minus nothing times 0 produces a volume of 0. In fact, from 10 minus 2 times 5 makes a 10 minus 10, so 5 is an x-intercept. 20 minus 2 times 10, 10 being another x-intercept, produces the last of our 3 x-intercepts. So this isn't perfectly drawn because this should be right in the middle, but you can kind of see that there is a few different critical places here. What we're looking for is this maximum. You might think, well, doesn't the maximum just continue to get higher and higher? Is there no maximum? Which sounds strange. Well, if you pick, for example, a number like cutout of size, say, 6, imagine logically what would happen if you cut out 6 and 6 from a length of 10. You cut out 12 and you only have 10 to start. Logically, that doesn't make sense. Imagine cutting out 7 or 8 or 9 or 10 or 11. In fact, all of the values to the right of 5 don't work. Any negative values for x don't work. So as a bit of a domain for this context, I might say not including 0, not including 5, but everything in between is a possible value to cut out. Again, the question is, what's the size of x that produces the perfect volume? This is a calculator question where we are going to type in a second trace maximum. We do have to define a left side, right side, because there is an infinite height to this. So we'll define where the calculator should look. The left side of the max, the right side of the max, and the best cutout is 2.113 and so on inches, and the perfect volume will be 192.45 cubic inches. So we've just defined the perfect cutout at about 2.11 and the perfect volume at about 192.45 cubic inches. So what's the maximum volume? 192.45 inches cubed when the size of the cutout is about 2.11 inches. Finally, have a quick look at page 109 in your textbook for an overview of function names. There is a constant, degree of 0, and then there's a degree of 1, 2, 3, 4, 5, and that's the highest degree you need to know a name of. Eventually, you will be asked to sketch a, say, quartic function, and you need to know what that looks like. Good luck.